Hi everyone, this is Teacher Lou from Delta Learning Space. So today we are going to be doing a revision of fractions and decimals, and this video is a part of our number property series. Before we get started, there is a guided notes PDF available in the link in the description. This PDF is intended to help you follow along with the concepts presented in this video, as well as provide you the problems presented in each guided practice. In this video, we are going to be speaking about both fractions and decimals, and both fractions and decimals are a part of our real number system. First off, we will be taking a look at fractions, and all fractions will be rational values. In this video, we will be looking at what are fractions, the types of fractions, and conversions between fraction types. So, what are fractions? Fractions represent part of a whole number. Fractions can be represented as a ratio of one integer over another. As we saw in our types of real numbers, we have integer p over integer q, with the only restriction being that q will not be equal to 0. Fractions are helpful when we want to represent values in between whole or integer numbers. They will represent numbers in between, for example, 0 and 1, 1 and 2, 0 and -1 and -2, and are an important part of our number system. And so we can represent this as a part to a whole. When we write fractions, we will have a numerator, which is the part and will be shown up top, and a denominator, which will be the whole, shown on bottom. We will also have a fraction line, and this fraction line will separate the numerator from the denominator and also represent division. Now let's take a look at a graphic to represent fractions. Here we have a circle cut into 4 equal pieces. And so the 4 pieces will make up the whole, and that will be our denominator. If I were to shade one part of this circle, I would have 1 out of the 4 pieces shaded, and my part would be 1 located in the numerator spot. I could continue this and shade 2 equal parts. Two would now be my new numerator because I shaded 2 parts, but I still have 4 equal parts making up this whole circle, and so my denominator would not change. And I can continue and shade 3 out of the 4 pieces, and so my part and numerator would change to 3. And lastly, I could shade all 4 pieces, and my numerator would change to 4. And if I have shaded 4 out of 4 pieces, that could be represented as 4 over 4, but that will also be equal to 1 because I have shaded all the parts out of these 4 equal pieces. Here we have another representation of fractions. All of these will represent 1 unit. And so for fractions, we cut units into equal pieces. Our orange block is cut into 2 equal pieces, making it 1/2 and another 1/2. And if I were to add those 2 halves together, I would have 2 out of 2, making 1 whole unit. My light brown is cut into 3 equal pieces as a third, another third, and our final third. equaling 3 out of 3, or 1 whole unit. I can continue that with my force. To have 4 out of 4 equaling 1. And then I can continue that with my fifths, which would have 5 out of 5 total pieces equaling 1. And with my 6 out of 6 equaling 1 whole unit. And so all of these represent the same amount, but are divided into a different number of equal pieces. And fractions can be helpful in that way because there are going to be certain scenarios where we want things divided into halves, or thirds, or fourths. And those are going to be the most representative or the most accurate to the values that we are trying to represent. And as you can see, there will be some equivalency between different divisions in fractions, but we will save that for another video. Today, we are not simplifying, making equivalent fractions, or finding the least common multiple. We are simply providing a brief overview of what fractions are. And there are 3 types of fractions that we see and use. The first one that we have are our proper fractions. Proper fractions will have a numerator that will be less than a denominator. Some examples of proper fractions will be 1/2. Our numerator 1 is less than our denominator 2. 3/4. Our numerator 3 is less than our denominator 4. And 5/8. 5 is less than 8, making all of these proper fractions. Proper fractions will be less than 1. Our second type of fractions are our improper fractions. Improper fractions are when the numerator is greater than or equal to the denominator. Our first example of an improper fraction would be 2/2, because our numerator 2 is equal to our denominator 2. And like we saw, 2/2 will equal 1. Another example of an improper fraction would be 4/3. Our numerator 4 is greater than our denominator 3. And our last example will be 8/1, where our numerator 8 is greater than our denominator 1. Improper fractions will equal 1 or greater. Our final type of fraction will be our mixed numbers. Mixed numbers will be an integer plus a proper fraction. Our first example will be 4 and 1/2. 4 is our integer value, while 1/2 would be our proper fraction. Our second example would be 7 and 3/4, with 7 being our integer and 3/4 being our proper fraction. Our last example will be 11 and 5/8, with 11 representing the integer and 5/8 representing our proper fraction. And all of these values can also be both positive and negative, but for this video, we are going to focus on the positive values of this. And with our 3 different types, our proper fractions will be representing values less than 1, because our numerator will be less than our denominator. Our improper fractions and mixed numbers, though, will represent values 1 or greater. Depending on our purpose or the type of operation that we want to complete, it is important that we are comfortable converting mixed numbers to improper fractions, and vice versa. The first one we are going to look at is converting mixed numbers to improper fractions. And here we will convert the following mixed numbers. Let's take a look at A, 3 and 1/2. When I convert mixed numbers to improper fractions, I start with the denominator and I will make a C arrow to the numerator. I will add a multiplication and then an addition, because what I am doing is I am taking the denominator, multiplying it by the whole number, and then adding the numerator. So starting from my denominator 2, I will multiply that by the whole number 3 to get 6. I will then add the numerator 1 to get a total of 7. This value 7 will be written in the numerator and our denominator will stay the same. We will not be changing the denominator of any of these values. We will only be converting to an improper fraction and writing an equivalent numerator. So 3 and 1/2 will equal 7/2. For B, 7 and 3/4, we will do the same thing. Start with the denominator, draw a C arrow to our numerator, multiply and add. Take my denominator, multiply it by my whole number, and then add the numerator. First, I will multiply 4 by 7 to get me 28. Then I will add 3, and that sum will be 31. 31 will be my new numerator, and my denominator is staying the same at 4. And so 7 and 3/4 is equivalent to 31/4 as an improper fraction. Our final example is 1 and 7/8. Start with a denominator, draw a C arrow, multiply, and add. My denominator 8 will multiply by my whole number 1, and then it will be added to the numerator 7. 8 times 1 will be 8. 8 plus 7 will equal 15, and this will be my new numerator. And my denominator will stay the same. 1 and 7/8, rewritten as an improper fraction, will be equal to 15/8. Now take a moment, pause the video if you need to, and try on your own to convert the following mixed numbers to improper fractions. Let's take a look at our answers. So for A, 4 and 2/3 as an improper fraction will be 14/3. For B, 5 and 1/2 as an improper fraction will be 11/2. And for C, 2 and 7/9 as an improper fraction will be 25/9. How did we do? Now it's time to look at the conversion the other way. If we can go from mixed to improper, we also would like to be comfortable going from improper to mixed. So here we are going to convert the following improper fractions to mixed numbers. We will first take a look at A, 9/5. And so remember when we were talking about what are fractions, this line here will represent division. So we can view this like 9 divided by 5. Our numerator 9 will go on the inside, while our denominator 5 will go on the outside of our long division. 5 can go into 9 once. 1 times 5 is 5. 9 minus 5 is 4. And since there's no other value to drop down, our 4 will be our remainder. This remainder will go in the numerator position of our mixed number. Our whole number up top will be 1. My remainder 4 will be the numerator. So just like how we weren't changing the denominator in our last set of conversions, we are not changing the denominator in this set of conversions. Our improper fraction, 9/5, will be equal to 1 4/5 as a mixed number. And the way that we convert improper fractions to mixed numbers is we divide the numerator by the denominator. Let's take a look at B, 25/3. Our numerator will go inside of our division. Our denominator will go outside, and then I will perform long division. 3 cannot go into 2, but 3 can go into 25 8 times. 3 times 8 will be 24. 25 minus 24 will be 1, and that will be my remainder. This 8 up here will be my whole value. So I will have 8 and 1/3, because again, I am not changing my denominator. The improper fraction 25/3 as a mixed number will be 8 1/3. Our last problem C, 46/7. 46 is our numerator and will go on the inside of our division. 7 can go into 46 6 times. 6 times 7 is 42. And then 46 minus 42 will be 4, and that will be our remainder. 6 will be our whole number. We put our remainder in the numerator position, and we do not change our denominator. The improper fraction, 46/7, will equal 6 4/7 as a mixed number. Now take some time, pause the video if you need to, and convert the following improper fractions to mixed numbers. Let's take a look at our answers. For A, 33/4 as a mixed number will be 8 1/4. For B, 65/8 will be 8 1/8. And for C, 70/3 as a mixed number will be 25 1/3. How did we do? Now we are going to take a look at decimals. Decimals can be both rational or irrational, but today we are only going to focus on rational decimals. Those will be decimals that terminate or repeat. We will be looking at what are decimals, the relationship between decimals and fractions, and conversions between the two. So what are decimals? Decimals also represent part of a whole number like fractions do. However, decimals are based on fractions out of 10, 100, 1000, or any power of 10. So here I have my 1 unit split into 10 equal pieces. That means my denominator will be 10, very similar to what we saw with our fractions. If I were to shade one piece, I have now shaded a tenth. As a decimal, this will be 0.1. This place value here, immediately to the right of our decimal, will be our tenths place. If I were to shade a second piece, I would have now shaded 2/10 of my unit, and this would be represented as 0.2, with this numerator being represented in the tenths position. I can now cut this unit into 100 equal pieces. Now my denominator will be out of 100. If I were to shade 9 out of 100 pieces, my fraction would be 9/100. As a decimal, this would be 0.09, with my 9 in my hundredths place. My numerator here, that last digit will end up in the place value of hundredths. If I were to shade that final piece in that column, I would have 10 out of 100 pieces shaded, or as a decimal, 0.10, with now that last digit of my numerator in the hundredths place. And for decimals, sometimes when the last digit is a 0, we can simplify it and simply say 0.1. We also know that this is equivalent to 1/10. I can continue to shade this and shade 4 more pieces. This would now be 14 out of 100. And as a decimal, this would be 0.14. Again, with that last digit in that hundredths place. And so in those two examples, we saw two place values, the tenths and the hundredths. With decimals, those place values tell us the denominator of that fraction. This will be out of 10, out of 100, and then would continue to out of 1000 and 10,000, and that would continue in this direction. Place values to the left of our decimal point will represent whole numbers, and place values to the right of our decimal will represent our decimal values or those parts to that whole. And these place values can extend in either direction to the left, with a number getting bigger, or to the right, with those place values getting smaller. Digits to the left will always be bigger than digits to the right. We just saw that fractions and decimals are very much related, and depending on what we're given, what operation we would like to do, or how we would like to represent our numbers, it is important to be able to convert decimals to fractions and vice versa. First, we are going to look at how to convert decimals to fractions. In this guided practice, we are not worrying about simplifying, we are simply going to practice how we can do that conversion. Let's take a look at A, where we have the number 0.70. I would take a look at that last digit, and that's going to tell me the place value that I would like to end at as a decimal. Because my 0 is in my hundredths place, I can represent this as 70 over 100. This value here I can simplify, but for this purpose right now, we are going to leave it simply as 70 over 100. For B, I would take a look, and my last digit, 7, is again in my hundredths place. And so this would be out of 100. And I would put that decimal value 7 in the numerator position. And so these two values are important because 70 over 100 is very different compared to 7 out of 100. So we want to be very careful with these conversions and how we represent these. For C, we have a number left of the decimal, and so that is going to be a whole number. And so for this conversion, I am going to make a mixed number. This will be 1. For my decimals, I will still take a look at that last digit. This last digit is in the thousandths place. And so this will be out of 1,000. And this decimal will go in our numerator position. So this will be 1 and 103 over 1,000. And finally, D, 0.2359, taking a look at 9, which is my last decimal place, that will be in the 10,000ths, meaning my fraction will be out of 10,000, shown in the denominator, and this will be represented in the numerator. Just as a recap, 0.70 as a decimal will be 70 100ths. 0.07 as a decimal will be 7 100ths. 1.103 will be 1 and 103 1,000ths. And 0.2359 will be 2,359 10,000ths. Now take a moment, pause the video if you need to, and convert the following decimals to fractions, writing them as either proper fractions or mixed numbers. Amazing, let's take a look at our answers. A, 0.23 as a fraction will be 23 over 100 or 23 hundredths. B, 0.09 will be 9 hundredths. C, 3.47 will be 3 and 47 hundredths. And lastly, D will be 6,103 10,000ths. How did we do? And just like with our fraction conversions, we want to be comfortable doing the conversion both ways. And so if we can convert decimals to fractions, we must also be comfortable converting fractions to decimals. And so in order to convert fractions to decimals, we must divide. Remember that this line here represents division. And just like when we were converting improper fractions to mixed numbers, our numerator will go on the inside of the division while our denominator will go on the outside of that long division. So I will put my number 1 on the inside and the denominator 4 on the outside. What is going to be different is that I am going to continue the division even though there's no more whole numbers to drop down. What I am going to do instead is put a decimal point and add zeros. I will also put my decimal point up above, and I can add zeros because this does not change the value underneath that division sign. 1.00 is the same as 1. And so this allows me to convert from a fraction to a decimal. And after the initial setup, I complete the division the same. I look and see how many times can 4 go into 1, and it can't. And so I'm just going to put a placeholder 0. 4 goes into 10 2 times. And I'm going to treat this number like a 10, not 1.0. 10 minus 8 is 2. And I can drop this 0 down. 4 can go into 25 times. And because there's nothing left over, this will tell me that I am going to stop my division. So 1 over 4 is equal to 0.25 as a decimal. Now let's take a look at B. 2 is my numerator, so it will go on the inside of my division. 3 will go on the outside. I will add a decimal there and there, and a few zeros. If I need to, I can always add more zeros to the end. 3 cannot go into 2, so I will put a placeholder 0. 3 can go into 20 6 times. 6 times 3 is 18. Again, treating this not as 2.0, but as 20. 20 minus 18 is 2. Drop down a 0. 3 can go into 26 times. 6 times 3 is 18. I would get another 2, drop a 0 down again, and this is going to repeat. So 2/3 as a decimal will be 0.6 repeated. For 5 1/2, when I do this division, I am going to split the whole number from the proper fraction and simply do the division with the proper fraction. So I am going to put 1 on the inside, my denominator on the outside, add a decimal there, and a few zeros. 2 cannot go into 1, so I'm going to put a placeholder 0, but 2 can go into 10 5 times. 2 times 5 is 10. I will have nothing left over, meaning I can stop dividing, and then I can add in my whole number, put my decimal point, and then add the decimal that I just calculated. So 5 1/2 as a decimal will be 5.5. And so C taught us how to convert a mixed number fraction to a decimal. And so D will show us how to convert an improper fraction to a decimal. And so I am going to do this in the same way that I was doing A and B. I am going to put my numerator inside that division with my denominator on the outside. I'm going to place a decimal there and there, and add a few zeros. And again, I can do this because 25.00 is equal to 25. I'm not changing the value underneath. 8 can go into 25 3 times. 3 times 8 is 24. I would do that subtraction. 25 minus 24 is 1. I would drop down a 0. 8 can go into 10 once. 1 times 8 is 8. 10 minus 8 is 2. I can continue to drop down these zeros. 8 can go into 20 twice. 8 times 2 is 16. 20 minus 16 is 4. Drop down a 0, and I'm running out of space here. But that's okay because 8 can go into 45 times. 8 times 5 is 40, and so that would leave me with nothing else. And so I can stop that division there, and 25 over 8 is equal to 3.125 as a decimal. Now take some time, pause the video if you need to, and practice converting the following fractions to decimals. Amazing. Now let's take a look at our answers. For A, 1/3 will be 0.3 repeated. B, 5/8 will be 0.625. For C, our mixed number, 9 1/4, will be equal to 9.25. And our improper fraction, 56 over 5, will be equal to 11.2. And when we're converting fractions to decimals, we should always end up with either a decimal that will terminate or repeat. Amazing, y'all made it to the home stretch. Lastly, there are some fractions that show up a lot more than others, and so it is important to have these conversions ready to go. And so on the last page of your guided notes, we have this table for you to convert the following fractions to decimals. So pause the video, take some time, and convert the following fractions to decimals, so that way you can have this as a resource later. I have also filled out this table for you if you want to copy it down. In addition, if you have a calculator, you can always do these divisions in your calculator. You would do 1 divided by 2, numerator divided by denominator always, and these will get you those same values. Thank you for watching and thank you for learning with us. Keep up the great effort. We're super proud of you and grateful for you to take the time to learn with us. If you would like some more practice problems, there are some problem sets provided in the link in the description. Have a great day. We'll see you later.